Hi everyone, welcome back again. Now I'm thinking about to do the next lab of the Kubernetes series from the level 2, not from the level 1. So today is for the day 2 and the title is Kubernetes Sidecar Containers. Actually, I think this lab is similar, the same as the previous lab from the 100 days of DevOps series. So if you are doing the 100 days of DevOps challenges, I think you already know this lab. So but now we're gonna do it again. So okay, let me click the start button and then let me go to error.log and then let me go error.log. So I'm gonna explain with an architecture diagram. So this is the Kubernetes port. So we have this port. Okay, we can think like that. So okay, this is the Kubernetes port. Okay, so within this port we have a container. Okay, this is a container. Okay, now we're gonna read the given instruction. Okay, let me copy first. Okay, great. Let me move right here. So here we have a web server container. Okay, so this container is web server container. Okay, this container is web server container. Great. So that is running with the nginx image. The access and error logs generated by the web server are not critical enough to be placed on a persistent volume. So they think that way. However, the Nautilus developers need to access to the last 24 hours logs. So to access, they need to access last 24-hour logs. So this is the key point, right? So okay, this is the requirement. Okay, I was changing the red color. So that they can trace issue and bugs. And here to trace issue and bugs. So this is also key point. So okay, great. So therefore we need to shift the access and log errors here for the web server to a log aggregation service. So now they are thinking about to create a log aggregation service. So this is also a requirement, right? So following the separation of concerns principle, that means for a specific problem, we can solve the problem by the separation of the concerns principle. Probably first of all, the initial stage is like that. For a service, they just only use one container. Now they change the way they use two containers for a service according to this separation of concerns principle, right? So here we implement the Sidecar container, a Sidecar pattern by deploying a second container. So now we're gonna have to create a second container, right? So second container is like this. Okay, this is a second container. So let me change the color. So this is the requirements. Okay, so this is a second container. Actually, we can call it like the Sidecar container. Okay, great. So Sidecar container that ships the error and access logs from nginx. So nginx does one thing and it does it well. Subbing web pages. Okay, nginx mainly for web server, right? So the second container also specializes in its tasks, shipping logs. Okay, so same containers are running on the same pod, so we can use a share empty directory volume. So okay, so I will draw a diagram like this. So we have it share empty logs. Okay, this is a share empty logs, so we can understand like this. Okay, where is that? Okay, great. Okay, so this is a share empty logs, a share empty volume directory. So these containers are connected with this empty directory volume, right? So the direction is like this. Okay, this is connected with like this. and this is also connected with like this. So this web container will receive user incoming request through the internet, right? So this is a user incoming request. User incoming request to web pages from internet, across internet. I enter anything internet. Okay, so this web server container, this is a web server, right? Nginx, anyway, we can write nginx container. So this nginx container will generate or write new logs. So write access or error logs from this incoming request, right? So let me change the color. Okay, so this Sidecar container read or access or read logs, right? From the same volume, right? From this empty directory. Okay, the process like this. So here we will read it carefully. So port name is web server. So port name is web server. So this is port name web server, and then here empty directory volume name is share volumes. So here the volume name is this share volumes or share log, sorry, and regular container in the web server port from the nginx latest image. Name is nginx container. Okay, this is a regular container. So Sidecar container use ubuntu latest image. So this is a Sidecar container, right? This is a name. So with the ubuntu latest image. So this is the, okay, great. So okay, we keep reading. Here we have to add the following command to the Sidecar container. So Sidecar container, we have to add this command. So this is for the Sidecar container. All right, wait. So we have to add this command to the Sidecar container. So here, remember this, Sidecar container is a kind of any container, not a regular container. Remember this, regular container and any container are different, not the same. So okay, great. So but we have to mount the share logs volume in both containers, right? So here we connect these two containers are to this empty directory volume. Great. So here is a volume mount pad. So here ensure all containers are in a running state. So that we have to do for verification, right? So this is a volume mount pad. Okay, so this is the workflow diagram of this lab. So here, first of all, we have to create a port. So to create a port, I will use bin editor. Let me give the same name, web server. And then I will give Sidecar. And then I will give port.yaml. Let me get like this. So here I have to write YAML codes and commands line by line. So I don't want to write like that. So actually I get bored. So this is kind of like stupid way we will use that. We will copy it and we will find the Google directly. So I will copy this. So here, and then I will paste right here. So here everything's correct, I think so. Port name is correct. And this is a volume name and empty directory. So this is for the nginx container. You will see that this is a container, regular container. So here nginx latest image and tag. And this is a volume name, volume mount name. And this is a volume mount pad. Here's any container, not the same. Any container is Sidecar container. So here is a command. So that will work after 30 seconds sleep. And then here is volume mount name is the same. Mount page is also the same. So here, remember this, bear in mind, this is very important. Any container is actually not, like, it is not working 24 hours. Like, after creation of any container, it will start automatically. So not to store like that, we had to make the restart policy is always. So here we need to add the restart policy argument for this any container. So you shouldn't forget this. This is imperative. So restart policy. So you should add this argument and value. So that is always. So if you don't add these values, it will stop immediately. So it will not create that in a container, and it will not create this nginx container. So they will not work together. So you will see the errors. You will see, you will see any run. You will not see any running pod and containers. So here we need to add this argument and value. Okay. So I will save it. Applying this. So k applying dash f and web server port YAML. So here port and web server is successfully created. Let me check the kget port list. Okay, here 1 out of 2 is running. So let me check it again. Okay, yeah, now 2 out of 2 is actively running. So now let me try to access to the Sidecar container here. Let me try to access to the Sidecar container to access and read logs for the real-time logs. So okay, so we had to, access to this Sidecar container to see real-time logs. Okay, so we had to write a command for this. So let me get the right command. So k logs -f, and then we had to get this web port name, Kubernetes port, and then we had to get a specific container. So now we had to do for the Sidecar container. So I will copy this name, and now let me see the real-time logs. So now we don't have any incoming requests from the nginx server. So let me send request to this nginx web server. Sorry. Send request and send request to this nginx server. Okay, now let me enter to this web server container. So okay, let me open new terminal. So here without entering to the web server container, I think we can get the public IP address of the nginx web server container. So let me check here, get port -o white. So I will use this IP address, and then let me try to access with the HTTP. Okay, here we see that welcome to nginx. So let me check here the logs, real-time logs. So probably after 30 seconds, because sleep time is 30 seconds. So we will see this incoming request log here. So now you will see that here get request here with a CURM. Okay, so you see the incoming logs. So now we can track the here 24 hours of logs from this in a container log aggregation service. Okay, now one more thing is, let me try to enter to this nginx container using exec-it web server and specific container nginx container, and let me run with a bash. Okay, so let me send request here with the localhost. So here you will see one more time right here, and also let me send the error log, something like that. Localhost 304, something like that. Okay, so here you will see the new incoming request through the nginx web server. So now we can read the incoming request log access logs from this Sidecar container. So now here you will see that here error log. So this is the error log. Okay, this is a third request from this nginx container. Okay, so now let me check it out. Click confirm. Yeah, finally it's been successful. So here, if I can do it, you can also do it too. So I will start here. Click yes, no issue faced, submit. Yep, so thanks for watching. See you in the next coming video. So the key point is to understand this workflow process of this left. So if you really grab the concept, so you can do it too. That's fine. So alright, so I will catch you in the next coming video again.